Okay, let's work a time of death problem. Here we have the coroner arriving on the scene of a homicide. She gets there at 10 o'clock. We know that the room is 70 degrees. When she gets there at 10, she takes a temperature of the body and finds that it's 92.4 degrees. So then she takes some time doing some other stuff, letting some time pass for the body to cool. 30 minutes later, she retakes the temperature and finds that it's 91.8 degrees. And so we want to use this information to estimate what time the person died. So we're going to be using our cooling rate formula, T minus C equals T0 minus C e to the negative KT. And remember, our first order of business is to calculate the K, which is the cooling rate. And so to do that, we need to find out how much the temperature's dropped in that 30 minutes. So the temperature at the end of the 30 minutes was 91.8. Our C is our room temperature, which is 70. Our initial temperature at the beginning of the 30 minutes was 92.4. Once again, C, the room temperature, will be 70. E, negative K is what we're trying to find. And our little t is the time. This took 30 minutes. So if we start subtracting 91.8 minus 70, that leaves us with 21.8. 92.4 minus 70 leaves us with 22.4. E, and then I'm just going to put the 30 in front of the K because we're used to seeing the number in front of the variable. All right, so now let's solve this for K. We want to get the K by itself. So the first thing I need to do is divide by the 22.4. I'm going to do this all in a series of steps without writing it all down. So we take the 21.8. We're going to divide it by the 22.4. Then we need to get rid of the E. We do that by using the ln. So we're going to take the ln of all this. And then we're left with negative 30K. So to get the K by itself, we divide everything by negative 30. And that leaves the K by itself. And now if we put all this into the calculator, ln 21.8 divided by 22.4, close the parentheses, all that divided by negative 30. Depending on your calculator, you might get an E or a negative 4 in there. That just means to move the decimal over 4 places. So if we do that, we end up with 0.0009. Some of you may get that exactly on your calculator. Some of you may get something that looks like 9.0503, and then some notation and then a negative 4 somewhere. Well, that just means to move the decimal 4 places in front of the 9, so the 9 becomes the 4th decimal place. All right, so we've got our cooling rate. So now let's figure out how long the body has been there. So we're going to come back up to our cooling rate formula. Okay. This time, our T is going to be the ending temperature. And this time, the ending temperature would be from the time the person died to the time we got a temperature that we know. And you could use either the 92.4 or the 91.8. I'm going to use the 92.4. And what we need to remember about that is that's the temperature at 10 p.m. So when we get our final answer, we count back from 10 p.m. Okay, so our T, 92.4. Room temperature is still 70. Okay, what's the initial temperature? Well, this would be the temperature when the person died, so we're going to assume that that was 98.6. We'll assume they were a normal, healthy person. Our other C would be 70, again. E, now this time we know K, it's 0.0009. And this time we're looking for the little t. Now the steps are going to be exactly like what we did before, just with different numbers. 92.4 minus 70, that's 22.4. 98.6 minus 70, that'll give us 28.6. And the rest of this stays the same. And just like before, if we want to get the t by itself, we have to move all this around. So if we start with the 22.4, first we're going to have to divide by the 28.6. Then to cancel the e, we're going to use the ln, the natural log. And then to get the t by itself, we're going to divide by the negative 0.0009. Okay. So now we go to the calculator again. ln 22.4 divided by 28.6, close parentheses, divide by negative 0.0009. And we get t to be about 271 minutes. So by the time the coroner found the body had been there 271 minutes. So we need to convert this. Let's use hours and minutes. Well, there's 60 minutes in 1 hour. 4 hours would give us 44 times 60, 240. So that would give us 240 out of this 271. So we subtract that away. That leaves us with 31 minutes. So 271 minutes is 4 hours and 31 minutes. Okay, so what time would that be? Well, we know this was the time, we calculated it for when the body was found at 10 p.m. So this means the body had been there for 4 hours and 31 minutes. So if we go back 4 hours, that gets us to 6 p.m. And then if we go back 31 more minutes, that hits us a time of 5:29 p.m. for the estimated time that the person died.